Welcome, welcome, welcome to Correct Science. Today we are going to solve an amazing math question on logarithms. Without wasting my time, let's take a look at the question. This is the question. You can pause the video to try it on your own and later watch to clarify your answer. So we have log 9 to the base 2 squared multiplying 1 on log 9 to the base 2 to the base 2, or that multiplying root of 7 to the exponent 1 on log 7 to the base 4. This is a nice question. Let's solve it together. But before we do that, I would like us to note a few points. Okay, so the first thing we have to note is that when we have x log raised to the exponent log y to the base x, the answer is always y. Let me give an example of this. So 10 to the exponent log 100 will give us 100. From what I'm saying, we know this is the same as log in the base 10. But this is actually true because we know log 100 to the base 10 is what, 2, and we are getting this. It's true, but how did we even realize that? How can we get that? Okay, so that's what we'll be doing in a few seconds to come. Why? So let A be the answer to this question, the solution. And so we are saying log y to the base x to the exponent log y to the base x equals A. A is our answer. Now we are going to prove that A equals y, meaning that our answer is what, y. Okay, so express this in logarithmic form. So we know that anytime we have A to the exponent b given us in logarithmic form, base A equals b. So here what's our A? Look at it critically. Here our A is what? X. Our b y to the base x. Now C is capital A. Wherever you see A here, you place X there. Wherever you see C, you place capital A there. Wherever you see B, you place log y to the base x. Let's see what happens. Good. So we have log A to the base x equals log y to the base x. This is our B. This is our B. This is our A. This is our C. So we've done it. But now we realize that they are both in the same what? Base. Since they are both in the same base, A equals y. Very simple. So we can therefore say that x to the exponent log y to the base x equals what? Y. Good. I want us to note another thing too. Log x to the base a equals 1 on log a to the base x. So here we swap the bases. And when we do that, it means it will be the reciprocal of the other. So let me give an example to explain this. So we have log 4 to the base 2. We are saying that it's the same as 1 over log 2 to the base 4. And this is actually true. We know we'll get 2 here. And we'll get 1 over 1 on 2 here. So 2. So it's the same thing. But how did we also get this one? So for this one, we got it from the change of base formula. Change of base formula. I hope by now we know the change of base formula. When I change it into base C, then log B base A equals log B base C on log A base C. Now, realize that here our C is what? X, because you can see X down here. It means it has been changed to base X. Whenever we see C in the change of base formula, we place X there. Whenever we see B, we also place X there, since here X is also here. Right. Okay, so when we do that, we have log x to the base a equals log xx log x to the base x on log a to the base x. And no, log x to the base x is 1. So 1 on log a to the base x. Proved. But how do we use this to solve our question? Let's look at the solution. Our question is back again. So how do we go about it? The first thing we have to note is that log x to the base a equals 1 over log a to the base x. But how can we apply this? So we see some 1 over something something here, right? So here, right here, what's our a? So this is our a, this is our x. If we compare it to this one, so let's try and write it in this form and see what will happen. So it means we'll swap it. So we get log 7 as the base of 4. So log 4 to the base 7. Now here too, what do we see? So we realize that this is our x, these two here is our x, and this is our a. So we swap and we remove the 1 over that thing, we just take it away somewhere. We have log 9 to the base 2 as our new base. So let's see how this will look like. Good. Gradually shaping out. But once we get here, you might be wondering what we can do again. Okay, we know from indices that when we have a to the exponent m, the exponent n, like multiplying it to the exponent n, is the same as what? A to the exponent m times n. So here too, we can have a similar, where here's our a, here's our m, here's our m. So multiply the 2 by the log 2 to the base log 9 to the base 2. So we have what? Okay, yeah, so we have that. And this one too, the 7 to the exponent half. We got it from root 7. We know that root 7 is the same as 7 to the exponent half. Okay. From that, we can move on to say that log 9 to the base 2 to the exponent 2 multiplying log 2 to the base log 9 to the base 2 multiplying 7 to the exponent half log 4 to the base 7. Wow. What else can we do here? Okay, so you remember this? Log x to the exponent n to the base a equals n log x to the base a. So here, realize that they are of the form n log x to the base a. These ones. So we just write it in this form. So we have this expression. When we do this, our work is almost done. Even though we are not done, our work is almost done. So we have log 2 squared, and that's 4, log 9 to the base 2, and log 7 to the exponent log 4 and 4 to the exponent half, and that's 2 to the base 7. We know 4 to the exponent half is the same as root 4. So we have this expression. Yes, it's shaping out very well. And I hope you remember this thing we said earlier. So here, what's our x and what's our y? Let's come back and look at it. So here's our x. You can see x here. So this will be our y. What about here? Here's our x. Here's our x. Here's our y. So the answer will be what? For here, the answer will be 4. For here, the answer will be 2. Then you multiply them. Very simple, right? Very, very simple. So it will be 4 times 2, and that's 8. This is our final answer. Thank you very much for watching this video. What's next in our following videos? We'll be solving more questions on logarithms, and we'll get to know more properties of logarithms. Keep on sharing and watching videos. Learn smart, not hard. Goodbye.